All right. In this lesson, we're going to continue the topics about function, right? We're going to continue to use the definition of function to see how the definition of function applies to the rules we are about to discuss. The next function we're going to talk about, in this lesson, we're going to talk about two functions, and then we're going to wrap up and summarize. And then before we go on to talk about more complicated functions in the basic function category. So square root of x, right? So what is this rule about, right? Certainly in this rule, we have input is x, and this rule says, give me the input, and I'm going to take a square root. I'm going to take the square root of the input. Okay, so that's what this rule about. All right, so the rule is that whatever input you give me, I'm going to produce a square root of the input. Okay, so this function assigned to each element x in the set of A, we're going to figure out the domain, exactly one element in the range, right? So here we have to figure out the domain. All right. On the other side, that's going to be in the range. So the rule is pretty straightforward. And we're going to figure out the domain, and we're going to figure out the range. Then, of course, we're going to do the graph, right? So before we do the graph, we like to pick up some points to calculate, right? From previous lessons, we have used we have started using the table because we see tables seem to be better organized. So let's try the table. Okay, so let's start with the table. So the input, output. Okay, and input, output, we have that ordered pair in order to make the picture. So the input we're going to choose, right? Because we don't know the domain yet. So we might be thinking, okay, well, I'm going to choose some negative number. I'm going to choose 0. I'm going to choose positive number. Say for negative number, for example, if I choose -1, if I choose -1, then it will be the input, right? And the rule will assign -1 a square root of -1. What is this number? We know that this number is no longer in our consideration of a real number because we're only going to be doing real number. For complex number, it doesn't have a place in the rectangular system. It cannot be plotted. So in this case, we say it is not defined, undefined in real number. Okay, we want to have exactly one output. That one output has to be real numbers. That exactly one output has to be a real number. Therefore, we cannot have a negative number as input. In other words, negative number cannot be in the domain. Can 0 be in the domain? Well, let's check out what value can be assigned, right, for 0. So when the input is 0, right, we assign to 0, doesn't have exactly one output. It does, 0. So now we got a point. We got a point. How about 1? No problem, no problem. So for square root of 1, when the input is 1, the output is 1, exactly 1. 1, 1. And you can choose, it seems that we can choose any positive number. We can choose 0 as input. We can choose any positive number input. And for each one of these inputs, we will get exactly one output as real number. So the output must be real number, because only for real numbers we can plot it, right? Our number rectangular system does not take complex numbers. So I'm going to just choose some numbers that are easy to calculate, and I can also choose fractions, decimals, whatever I like, right? There we go. So for input equals to 4, the square root of 4, and that equals to 2. So we got another point. All right. Feel free to choose more points, fraction, decimal, if you wish. For example, I can choose a decimal number, right? Say I'm going to choose 2.25, right? So what is, when the input is 2.25, what will be the output? It's going to be 1.5. So for that input, 2.25, the output is going to be 1.5. If you want to choose that fractions, no problem, go for it. So the domain now, we know that for this function, the input has to be all non-negative numbers. You cannot say all positive numbers. If we say all positive numbers, you have excluded 0. 0 can be in the domain. Therefore, all non-negative numbers. Or you can just use mathematical notation and say, hey, the domain, right? X represent the input greater than or equal to 0. So that's another way to express it. So what's the range then? If the input are all non-negative, look at these inputs we have chosen. Every input we have chosen is either 0 or larger. As a consequence, the outputs are what? They are all 0 or larger. So the range are the same, which is also greater than or equal to 0. Okay, you can also say all non-negative numbers. You can also say all non-negative numbers. And we can also have domain range in one sentence, which is the range greater than or equals to 0 for all input greater than or equals to 0. So we found the domain and range. So let's check out the picture, okay? So let me put the rectangular system right on the side of it. Okay, I'm going to plot the points. Please, you do the same with me. Get a piece of paper, pencil, right? The input can only be 0. So okay. So we're going to put the points in place. We have plotted these points. Go ahead, plot the points along my side. The first point will be 0, 0. The second point, 1, 1, input 1, output 1. The next one is 2.25, comma 1.5, input output. And you can plot as many points as you wish. And we're gonna connect the dots. So when we connect the dots, and here we go. The graph for f of x, which is having the rule of square root of x, square root of x. Domain range discovered. And you can see that this picture, in this picture, the output, right? Take a typical point, take a typical point. Say, I'm gonna take a point, right? This point is 2.25, output is 1.5. And what is 2.25? 2.25 is a horizontal measurement. Input. Okay, let me use a blue color. Okay, so this will be more consistent. Input is a horizontal measurement, right? Output is a vertical measurement. So 2.25, 1.5. So, and this piece is a positive. And that point is 0. Oh, so all the output are positive except this 1 point. So the range is at least 0. So the other word you say is it's at least 0. Okay. Yeah, that's the function. That's the function. Okay, so let's move on to the next function. Cubic root, cubic root. Okay, so I'm gonna do the same thing. Get the definition of function, comes with us. And the cubic root, of course, is another rule. It's another rule. All right, move this down. Cubic root. And this rule of the function is f of x equals to cubic root of x. So that's the rule. Okay, we're given an input, x, and this rule of the function says, I'm going to take the input, right? We assign each input. I'm going to assign the cubic root of it, the cubic root of it. And so that's the rule of the function. And it will give me exactly one output, exactly one output. Okay, so to each element in the domain, it has to have exactly one output. Otherwise, that number cannot be in the domain. Okay, so we are to determine the domain, and we are also going to determine the range. And last, of course, we're gonna graph the function, So let's see what is a domain and what is a range. Because we are considering real numbers, right? We're considering real numbers. You will naturally think of, hey, let me try some negative number. Let me try some positive number. Let me try 0, right? So we're gonna make a table. Okay, let me increase the number of rows. Okay, so please do this along with me. Input, output, and input output in ordered pair. Ordered pair. And then we're gonna make the picture, right? We're gonna make the graph. All right, can we choose negative numbers? Let's try -1. What is the cubic root of -1? What is the cubic root of -1? So what is f of -1? The cubic root of -1 is -1 because -1 raised to the 3rd power is -1. Therefore, for the input -1, we have exactly one output, a -1. And so in this case, -1 can be in the domain. So -1, 1 is as input, it has an output. How about 0? Surely that's 0, right? For the input 0, output is 0. So we assign the input is 0, exactly one element, which is 0. How about +1? +1, that input, after we take the cubic root, it still equals to 1. So far we have been chosen some pretty easy numbers. How about we try some other numbers? Say, how about -8? +8. Would you like to try that? When the input is -8 or +8, what do we get? You can pause here if you need more time. You got it. -2, because -2 raised to the third power is what? Is -8, right? And the cubic root of 8 is 2. So we got 2 more points. -8, -2. And from what we have done, it seems that the input can be 0, can be negative, can be positive. Therefore, we can tell our domain is from -infinity to +infinity. How about range? It looks like the output can be negative, can be 0, can be positive. So range is all real numbers as well. So let's graph. So we're going to put the points in place. Okay, let's do it with me. Get your paper, pencil. All right, let's put the points in place. -8 input, output is -2. Input a -1. I didn't choose any decimal numbers. We could. And 0, 0. 1, 1. Input 1, output 1. Input 8, output 2. We can choose as many points as we wish, right? So these are the dots. Look at the black dots. And we connect the dots. There. So that's the curve of cubic root of x, the cubic root function. In both directions, they will keep going on and on forever. So it can go as high as possible, okay? So we have discussed the first 8 functions, the first 8 basic functions. And what are we gonna do next to wrap this up is that we're gonna summarize. Okay? It's a very important skills for all of you as student, right? Especially you study math and science. Summarizing is a very, very important step in your learning process. Okay, go back to compare, look at the details, and so on and so forth. okay? So we have a function to summarize. Let's see how we're gonna do this. Okay, so I'm going to put a table here. Let's try it this way, okay? The first function we talk about is the constant function, right? It's a constant function. F of x equals to a constant. And we use the example of 2, right? We use the example of 2. And the second function we talk about was f of x equals to x. And f of x equals to x squared. And f of x equals to, let's see, what is this? X to the power 3, right? And then we cover that other function, f of x equals to the reciprocal of x. We haven't done the absolute value function x, okay? We're gonna do that after the summary. And f of x equals to square root of x, okay? And last but not least, we're going to do, we have done x raised to the power 3. I'm sorry, x taken root 3, okay? So these are the functions we have studied. So let's go back. And what do we have studied about them? We have studied about their domain range, right? So we have all these graphs. So we're gonna bring their graphs together, all under the rule, right? So this is the graph. So we have the visual. We have the visual, just make it a little smaller. And we also have y equals to x, right? That function, we graphed it. We summarize it. And the square, x squared, right? What is x squared right here? You see, when you summarize, at first you go back to the function, you study them, you look at similar similarities and things that's similar and things that are not similar, right? We have gone through all the details. We've gone through all the details. So it's about time to put them together. You can see that with different rules, we got different functions. We got different functions. So cube function, right? X raised to the power 3. Let's see. Oh, where did it go? Oh. Okay. Huh. That's a little interesting shape, but you know what I meant. And the software is just a little rebellious. What's going on? Okay, that's fine. I'm going to just keep going. X and 1 over x, right? It doesn't move about as nicely. We did it 1 over x is a reciprocal function, very important function that we did everything about it along with the summary, which you're gonna bring them back to and study the details. There we go. The reciprocal function. why that curve doesn't behave, right? It doesn't behave. And two more, right? So we're almost there. We are almost there. This cubic root, right? We have a cubic root. So this is the time that you do your own summary, and you may like to go into details, and then one more square root of functions. Where did the square root go? It's not far from us. Yep. It's right here. I'm going to make some adjustment to the view. There you go. There. Right, so we get all the graph lining up. All of the graph lining up, except this one, it's a little misbehaving. I mean, we remove it to see what happens. There. Is that behaving better? No. Well, I actually don't know what to do, but it doesn't really bother our overall scheme. And then we're going to look at the domain, right? So then we make the fonts just a little smaller to see if that would do better, right? The domain. So the next one, we're going to discuss the domain and the domain and range, right? So if you guys, we can go back, but we don't need to go back, right? The domain would be all real numbers, larger fonts, and all of these same domain, right? The cube function, that domain, why this curve behaves so weirdly? But anyway, this one, the reciprocal function we talk about, that domain is not the same, right? What is it? The denominator cannot be 0, right? And on this one, it's not all real numbers. It's actually the input must be at least 0. And the last one, yes, all real numbers, right? We have done all the points, all the details. So let's look at the range. Let's look at the range, right? The range for the constant function is just a single number. And that single number is whatever that constant is, And for this one, the range is the same as the domain. So the range is also the same as the domain. Okay, so you see that happens sometimes. And the range for x squared, the x squared function, right? Is it all real numbers still? Of course not. The range for this one is all non-negative number. Remember we talked about that, right? And so x squared is going to be at least 0. So that's the range. I'm using this notation. This is the preferred notation. Okay, I know there are multiple ways to represent these notation, but I want you guys to get used to these notation, which I think you may not have used very often. Okay, and the range for this one is all real numbers. Okay. We're going to come back to the reciprocal function. We're going to come back to the reciprocal function because that one has something very special, okay? So the range for this one is also, it's the square root greater than or equals to 0. And the last one, the range is all real numbers, Okay, so now we're gonna go back to our reciprocal function. This function is very special, very, very useful. And remember, we have that amazing summary done before. And we don't want that to be lost. We don't want that to be lost. Okay, so we're gonna go and put it here. We're gonna put it right here. And this is a very, very important summary. And some of you might have remembered, some of you have learned before, called horizontal asymptote, vertical asymptote. Okay, horizontal asymptote, vertical asymptote, yes, we have here. The vertical asymptote is the y-axis. The horizontal asymptote is the vertical asymptote is the y-axis. The horizontal asymptote is the x-axis. So I'm going to add another row here. Column there, sorry. We're gonna add one more column here, which is about the asymptote, right? This is gonna be the horizontal asymptote. Horizontal asymptote, horizontal asymptote. Okay, horizontal asymptote is the x-axis, which is y equals to 0. And we also have a vertical asymptote, which is the vertical, which is the y-axis. The y-axis, the equation of y-axis is 0. So we have these two asymptotes for this reciprocal function, okay? So we have horizontal asymptote and we also have vertical asymptote. And what does it explain this, right? So I'm gonna bring this one outside and just reorganize it a little bit. Okay, just reorganize it a little bit. Okay, so I'm gonna take this table and bring it out just to make it clearer. Okay, just to make it clearer. Okay, see, when x is approaching 0, x is approaching 0 from both sides, right? So what I'm gonna do is that I'm gonna remove this piece, right? And put these two pieces together. Okay, put these two pieces together. Insert another row. I'm just shuffling the place. Okay, so these two pieces and these two pieces, okay? These two pieces, this piece explains the vertical asymptote. The vertical asymptote is y equals 0, which is the, wait, I think I need to switch the place, okay? So I don't get you confused. I'm going to copy and paste. I'm going to bring this one outside because these two are the reasons for the vertical asymptote. And as they approaching zero, you see approaching zero. Okay, you can see it's approaching zero from greater than zero, right? So let me use some notation. All right, I'm going to use the blue. You can see that x approaching zero from smaller than zero. 175%. I need to make larger the fonts, okay? Even though this is calculus stuff, but I want to give you the proper preparation. So here, as x is approaching zero from both sides, right? We talk about this. You see it's approaching zero from smaller than zero, right? And the output goes to negative infinity, approaching to zero from larger than zero. And you can see that this approaching to negative infinity, this approaches to positive infinity. So that makes the y-axis, the vertical asymptote, okay? The vertical asymptote. The vertical asymptote, I think I messed up a little bit here, so I'm gonna correct it, right? So these two lines explain the vertical asymptote, which is a y-axis. The equation of the y-axis is x equal to 0, okay? The equation of y-axis is x equal to 0. Got it? So that's why I want to make the switch and change, because I don't want to confuse you. So here, when we are approaching 0 from both sides, you can see it's approaching a vertical line. This vertical line is y-axis. The equation of y-axis is x equal to 0. Okay, if you have any questions about it, so please ask me. Okay, so now let's explain the other one, horizontal asymptote. Horizontal asymptote. Okay, so horizontal asymptote, so we're going to put the reasons here. These are the reasons there. For horizontal asymptote, what are horizontal asymptote? I'm going to bring this picture to the side because they don't seem to fit in the same, because I want to show you these two lines, okay? For horizontal asymptote, you can see that when x is approaching negative infinity or input approaching positive infinity, the output is approaching 0. One is approaching 0 from smaller than 0. The other one is approaching 0 from larger than 0. So that's how we get the horizontal asymptote, because they both approaches the x-axis. One is from below, the other one from above. And that causes the x-axis is the horizontal asymptote, because x-axis is horizontal. But x-axis itself, the equation of x-axis is y equals to 0. Okay, so that's why I want to put these together this way. And these two, okay, these two support the horizontal asymptote, and these two support the vertical asymptote idea. Okay, so with that said and explained, and I'm going to put this table to replace the other table. Okay, to replace the other table. Okay, to replace that other table. Vertical asymptote there's no mistake here. Horizontal asymptote y equals 0, vertical. I just want to better organize it. There. So that way you understand, okay, previously there wasn't any mistake. It was just kind of, it needs a little bit shuffle, okay? So these two supports the vertical asymptote, and it gives us the vertical asymptote equation, which is the y-axis. The equation of y-axis is x equals 0. And these two supports the horizontal asymptote, which give the reason for, it's called horizontal asymptote, okay? So this hopefully is clear for all of you. If you have any questions, then please feel free to let me know. So I'm gonna, let me see if I can give you a better view of the whole thing. And this guy is really messing things up. Okay, so let me see if I can put it in a, I can put a better picture somewhere. So why this picture is so naughty? Why this picture is so naughty? Let me make some adjustment. Okay, so with that, to see if this will make a difference. Is it better? Huh. It just doesn't, it refused to do better for me. Let's see. Okay, never mind. It's no big deal, right? It's no big deal. You got it all. So that's how you summarize and put things together. And that's all for this lesson. If you have any questions, please don't hesitate to talk to me. And we're going to continue this in the next lesson. Thank you for watching and thank you for participating.